Thank you so much for the kind introduction, Mike. And can we also acknowledge how much of an effort and how much above and beyond Mike has gone and his team to make sure that these exceptional events happen. So can we give a round of applause to Mike as well, please? Alrighty, so I am Pamir, and today I will be slightly controversial in my presentation. And the reason for that is because I want to generate some good conversation here and make sure that we all converse to approach the objective truth and hopefully plan for the future and understand where this industry is going. That being said, my talk today is titled Vector Thrust, the Dominant Design for eVTOL Generation 1.0. Alrighty, so before I get into the real thesis, I'm going to give all of you how the design space looks like in passenger eVTOL today. Of course, you have the multicopters. They've been around the longest so far. 280 concepts, $1.5 billion in venture funding over the last 10 years. Of course, the lift and cruise. Slightly less amount of concepts. We have around 170 of them, but slightly more funding that has gone into this space, about $1.7 billion. And of course, the focus of my talk today is the vector thrust. And when I say vector thrust, I'm aggregating a few different design configurations here together. The tilt-rotor, the tilt-wing, the tilt-fan, the tilt-vane, and also the tilting body. And this sector has received the most amount of venture funding of all. Around $5.5 billion has gone into around 5 to 10 designs here. And the overall concept space is more than 330 of them, right? So you can see that already immediately the disparity here compared to the other designs. And I'm specifically talking about passenger VTOL, right? We're not talking about emergency medical or other use cases. So you can see that there is a momentum towards this. Before we dive into the specifics of what a dominant design for eVTOL passenger designs will mean, let's talk about what a dominant design is, right? So a dominant design, this concept has been around for the last 40, 50 years out of Harvard Business School. And it essentially is the industry defining design principle that most companies' competition in the space adhere to. You can think about it as a de facto standard model that everybody goes to for a specific use case. And this is true for hardware companies, software companies, and even service businesses, right? There's a way of doing things when an industry matures. And this is intricately tied to how a product goes through its life cycle, right? Over a decade or more. And it starts with the era of ferment. And this is when, you can think of this as the last 10 years of eVTOL, when a lot of designs have been competing with each other, a lot of company formation happening, competitions, and nobody really knows where eVTOL is going to take, right? And then a critical juncture happens in eVTOL, and that is the emergence of the dominant design. We still don't know what that will be yet, but we might have some signals that I will show you a bit later on that it is coming up, right? And thirdly, once the dominant design emerges in any product category, really, you have this era of incremental innovation. So an example from our industry would be where commercial airliners have been in the last 60 years, right? Since the dawn of the jet age, the tube and wing design has been the dominant design. And most of the innovation has happened either on efficiency and or performance or process innovation, right? So you get the idea. And couple, I'm not going to go into these, but IBM PC in the 1980s, for example, is really set the tone for the personal computer revolution today. Alrighty. Let me pass these. I have a lot of slides, but no time. All right, so let me dive deeper into what dominant design in aviation has meant over the history of our industry. So, if we look at fixed-wing aircraft, there are a few critical junctures, and 1930s was one of them, right? With the emergence of the Douglas DC-3. This really set the tone for what future, especially regional aircraft, would come to be. However, it didn't become the dominant design at mass scale. That was the DC-4, right? That became massively adopted in the global sense. All the way to the Douglas DC-7. So you can see the progression here. It takes several iterations to make it a mass market product. On the jet airliner scene in the 50s, we have the Boeing 367 come up. And again, this sets the tone for how a jet airliner should look like. Swept wings, tube and wing design, of course. You have perhaps somewhere between 2 to 4 engines that are at the front and below of the wings. But it was essentially commercialized at scale with the Boeing 707, right? Culminating in most of the airliners that we see today, from the Boeing 737 to the big Airbuses. Now, rotorcraft is an interesting story. It has adapted much more slowly in terms of what a dominant design would look like, only until the 50s and 60s, with the emergence of the Sikorsky S61. This really set the design principle for what a twin turboshaft, single main rotor, single tail rotor aircraft would look like, evolving all the way to the Bell Jet Ranger 206, right? So you get a sense of what a dominant design means for this. Now, it's the exciting part. Let's dive into eVTOLs, and I'm going to be showing you 3 different signals that I think that are really important, showing why I believe the vector thrust is emerging as a dominant design here. Oh, yeah. Number 1, the concentration of funding. I briefly mentioned this, but I cannot emphasize enough how momentum created by investors can actually shape an industry. And investors can be wrong. It doesn't mean that they're going to back the most technically elegant or most technically advanced product out there. Sometimes they do, but usually, more often than the case, they can shape what an industry will become and what a product dominant design will become. So again, $5.5 billion in aggregate funding for vector thrust. That's more than 2/3 of all funding that has gone into eVTOL passenger vehicles over the last 10 years. And if we look at some trends, the last 6 months, more than 50% of venture capital funding has gone into dominant vector thrust vehicles. Virtually none into multi-copter, especially in the United States, which is a really interesting metric that we're seeing today. Number 2, over the last couple of years, we have seen a few design pivots by well-known, prominent OEMs going into the tilt-rotor, right? So 2 main examples here. Number 1 is, of course, Wisk Aero. Their 6th generation vehicle is a tilt-rotor, but they've been, most of their development history, looking at the lift and cruise model, right? The Vertical Aerospace is another one. They start with a multicopter and it's tilt-rotor now. So you see that designs outside this vector thrust design space are coming in and actually imitating, right? And this trend is not only available for us external to this space, but also internally as well. There are companies that are converging their designs together. One example is, of course, Supernull's new generation vehicle and Archer's eVTOL vehicle, right? You can see some of the similarities there, and so on. So this is a very interesting trend that everybody needs to pay attention to. And finally, regulatory lock-in can be a significant force, right? So specifically with the FAA, with the issuance of G1 certification papers in the last couple of years, to my, available in the public knowledge, we know that all of them are either tilt rotors or tilt fans, right? Lilium, Joby, and Archer, to be specific. And, you know, obviously it doesn't mean that lift and cruise or multicopters won't be certified, but it means that if you're a company that is looking to enter the space or looking to raise, you know, big capital from VCs, you will have to think really hard on your strategy. Would you rather go for the tilt-rotor and go with regulation and, you know, certification papers that are already being issued, or would you rather, you know, be bold and go a totally blank way? Something to think about. All right. I'm an engineer too, so I know it can be frustrating sometimes when the technically best design, technically most elegant design does not become the dominant design, right? And there are several reasons that you should be aware of why this is usually the case. Market forces, consumer demand is really, really important for the long-term adoption of a dominant design here. So number one is, of course, path dependence. You know, business folks talk about this all the time. It basically means that if you have spent a decade building a vehicle, or spent hundreds of $millions designing a vehicle, setting up your partnerships, you will likely keep that going, right? So that's what path dependence is. You can't really go back and then get on a different path because the sunk costs will be so high. This is especially true for the companies that have raised more than $1 billion in this field. The second is, of course, standardization. As the tilt rotors and tilt fans have the most funding and perhaps the most progress in this space, standardization might favor them in certain respects. So this could be charging infrastructure. This could be how approach and departure paths are defined around certain vertiports, and so on. So this is something that we need to really think hard about to make sure that standardization doesn't favor a single design, right? And finally, something very obvious here is the manufacturing and the supply chain that OEMs set up. If most of the supply chain players are supporting tilt rotor and tilt fan vehicles, they will be more incentivized to do for other tilt rotor vehicles, right? Other tilt rotor companies. So there might be some lock in there as well, especially on the manufacturing side. If you set up your plant, if you set up your tooling and machinery, that will create some inertia for you to go on building the vehicle that you've already been building. So these are all very important for long-term product success. Okay, so the million-dollar question is, I guess this is where I will answer the controversial aspects of what this is. Will there be only one dominant eVTOL design, right? The short answer, my personal belief, is no. And here are some examples from helicopters, for example. You have tandem rotor vehicles, you have single rotor, twin turboshaft, you have the Cayman K-Max as an outlier, for example, or you have the V280 tilt rotor. So you can see the variety here, and the reason for that is because these all go after different use cases. Now, if we look at fixed-wing aircraft, the variety is actually greater because fixed-wing aircraft go after many more use cases than helicopters do. So you see actually multiple dominant designs that have emerged. Simple reason, because fixed-wing aircraft have a much greater performance range, right? So many more use cases they can cater to. And eVTOL, oh, it's not working, yeah. And my feeling is that eVTOL will be somewhere in the middle of this. They'll be able to access use cases that helicopters traditionally can't, let's say urban areas or low-noise military combat missions. But they will also be constrained by what fixed-wing can do today, especially because the eVTOL performance range is really going to be constrained by battery technology, right? So I think it's going to be more interesting than what the helicopter market looks today, but perhaps less of a variety than what fixed-wing is giving us. So there won't be one single eVTOL design, and the thing to think about it is There might be one for emergency medical, first response. There might be one for air cargo, right? Passenger VTOL. Perhaps there will be a specific one that will primarily operate out of airports using conventional takeoff landings and so on. So you get the idea. Okay, so is it all doom and gloom? Let's say you're a company in the space, whether you're a startup or a corporate. Do you really need to go after the dominant design of today to be successful? The answer is no. Although you can do that, you can jump on the bandwagon and reap the benefits in the future as everybody uses the same type of design. Or you can wait, maybe for generation 2.0 or generation 3.0 for eVTOL, and go after existing designs, maybe a decade into the future, and be successful there. And many examples for this in many different product categories, right? And finally, you can also find a niche. So, first response is one niche that perhaps tail sitters will become successful, or electric rotorcraft, let's say for tourism, just some examples here. But you can still make a lot of venture returns going after different parts of this matrix. Just don't be at the upper right corner. If you have the wrong vehicle for the wrong use case, you will probably fail, and that is the truth. Okay. So why should all this matter to all of us here? Engineers, researchers, companies? Well, number one, if we know, or if we have a good idea of where a dominant design will go towards, we should make our research more precise. Either exploring that use case, that vehicle a bit more, or looking at other use cases where the dominant design doesn't really explore, right? So then we can create an industry that is as varied as possible in terms of the design space. Harmonize the ecosystem, right? If we know where the dominant designs will be, we can put resources there for the enabling technologies, the supply chains, all of the value chain, right? So that we don't waste capital. And finally, what is special to me is startup success. And let me get into that. And I think this is really, really interesting. If you look at innovation theory and which products at what times have been successful, it's usually those products that are launched right before a dominant design emerges, right in the middle there. So there's this tiny window of opportunity that today we are possibly in that is a great time to create a startup and create products in this space, right? The reason for that is quite simple. If you have a dominant design emerging in the industry, the R&D and the technical risk and the ecosystem risk will probably be on the low side, so that whatever you do, as long as you get the use cases right, you will you have a good chance of having a big exit with your startup, for example. Okay, so this is all. I want to wrap up by saying I think this is a critical juncture that we're all in today, and I would love to be challenged on this because I know a lot of you probably have questions on this. But the important part is, as an ecosystem, the design choices that we will make today, and not just the eVTOL design, right? Let's say the vertiport design, batteries, flight controls, autonomy, is going to shape what the eVTOL industry will be like decades ahead, just like the Douglas DC-3 has, or the Boeing 707 has, even in the last 60 years. So, very important part. And I know I have 50 seconds. Thank you for listening to me, and happy to maybe answer a question. I don't know, Mike, if we have time.
Thank you. Hi, Rod Randall from Maglev Aero. First of all, first question is, did you make those pictures with ChatGPT?
I made a Mid-Journey, actually, yes.
So
Yep.
the second question is, do you remember when we had cell phones that had buttons on them?
That's right.
So Nokia, BlackBerry, and the others. And I sat in a dinner in Silicon Valley as a venture capitalist, with the CTO of Nokia when the iPhone was announced, and they said that this will never work. There are no cell phones with buttons anymore. So do you believe that there could be a next generation that is, in fact, completely different from a completely successful early generation?
I do, but unfortunately, I think it will take time in our industry because the fact that it's such a capex-heavy industry, you cannot iterate products with eVTOL as fast as you iterate smartphones, right?
Not necessarily.
So-
Smartphones is a multi-trillion-dollar industry, and it took a great deal to get there because it was network and devices, and it's not unlike that.
I agree. But imagine let's say, the $6 billion that has gone into tilt-rotor and tilt-fan and whatever, it doesn't work out, right? And if it doesn't work out, a lot of investors will, in my opinion, will lose interest to go after that in the next 10 years. And this is what happened with the air taxi revolution in the 2000s, right? So that industry totally died off and investor interest was lost. So I think that momentum is key here, but nobody says that the multicopter will be successful in generation 2.0 or 3.0, right?
And some of the players can still be leaders. Like IBM was a leader in mainframes, but they shifted, and they still are a leader.
Yep.
Thank you.
All right.
All right. Thank you very